Welcome to lesson 6B.2. We'll be writing equations for quadratics today, but we'll be doing that with linear pairs. So we will be focusing on this part today. So example 1, write the equation of the quadratic function graph below using linear pairs. This is similar to vertex form, but we're going to be using different pieces of information. It's still broken down step by step. So all you have to do is follow the steps all the way to the end. Step 1, identify 1, 0. Remember that a 0 is also known as an x-intercept. X-intercept, ordered pair is 2, 0. P is just the x value of the x-intercept. So P in this case is 2. Identify another 0. This is the other 0. So as an ordered pair, 4, 0. This time Q is the x value, so 4. And then step 3 is identify a third point. I'm going to go with the vertex here. So my vertex is at 1, 2, 3, 1, 2. So 3, 2, x is 3, y is 2. So once we have those key pieces of information, we're going to plug everything back in to this linear pairs form. F of x equals a times x minus p times x minus q. So p will be replaced here, q here, x, same value twice, and then we know that f of x is the same thing as y. So I'm going to plug in those key values that I already found from my graph here. So f of x, which is like y, is 2 equals a. We're solving for a just like in vertex form. Parentheses, x is 3 minus, that minus sign has to stay, it's part of the formula, 2 x again, so I'm going to write that 3 again, minus q is 4, and close parentheses. Now 2, can't do anything with it, it's going to stay the same. A is going to stay because that's what I'm solving for. 3 minus 2 is negative 1. Sorry, positive 1. 3 minus 4 is negative 1. So I'm going to multiply these two, because in this line that's all I can do to keep moving down and simplifying. So 2 stays the same, a stays the same. Positive 1 times negative 1 is negative 1. I have to get rid of this to get 2 by itself. So this is the same as if I had this. This is just backwards because the a is in front and the negative 1 is in the back. But it works the same way. I want to get rid of negative 1, so I divide both sides by negative 1. So a equals negative 2. Now, once you find negative 2, you're not done. The last step, we have to rewrite the equation using a, p, and q. So back up here at the top, in this linear pairs form, we're going to replace a, p, and q in our final equation. Everything else that I did not highlight is going to stay the same. So I will have f of x equals a, we already found, so that is negative 2. Then I have parentheses, x minus p, and I'll come back and replace it, and then x minus q, and I'll come back and replace that. So p is 2, and that's just coming straight from the information that we found from the graph. And then q is 4, which also came straight from the information that we found in the graph. So that's example 1. Moving on to example 2. Same process, different graph. So we're going to write the equation of this graph using the same steps. So 1, 0. Well, I can only see one here, right? So that is 7, 0. So P is 7. Now, I can't see the other end where my parabola intersects the x-axis, but I know that the axis of symmetry from 6A splits my parabola down the middle. So if my axis of symmetry is here, that means there are 1, 2, 3, 4, 5, 6 spaces between my axis of symmetry and this 0 or x-intercept. So therefore I need to move 6 spaces to the left to find the other x-intercept. So 1, 2, 3, 4, 5, 6. So I move 1 over. So this is -1, -2, -3, -4, -5. So my other, whenever I extend this parabola, it's going to intersect over here at -1, -2, -3, -4, -5, 0. So Q is -5. So we still have to keep using those ideas from 6A. We know that the axis of symmetry cuts the parabola down the middle, and it makes it 2 equal sides. So if there are 6 spaces between the axis of symmetry and this 0, then there has to be 6 spaces between the axis of symmetry and the 0 on the left. So now I can just finish it off. This is my third point, which is my vertex that is at 1, 9. So x is 1 and y is 9. So I'm going to plug everything back into the linear pairs form. Okay, so remember f of x is the same thing as y. So 9 equals a. A is what we don't know. X is 1. And then I have minus p, which is 7. Now, this negative makes a big difference here because this minus is part of the equation. It has to stay. This does not take place of that negative. So I would really have 1 minus -5. 2 negatives make a positive. So that is the same thing as having 1 minus -5. So that came from here. That minus has to stay as part of the equation. So when we have a negative here, 2 negatives make positive. So now I just solve for A. 9 stays the same. A stays the same. 1 minus 7 is -6. 1 plus 5 is +6. -6 times +6 is -36. A equals 9. Well, to get A by itself, I have to divide both sides by -36. A equals, don't guess, use your tools. 9 divided by -36, leave it as a fraction, -1/4. So once we find that A value, then I can go back and replace A, P, and Q. Those are the only 3 things we're replacing. Everything else stays the same. So f of x equals, A was -1/4. Then I have x minus p. I'll come back and replace it. And then x minus q. Well, p was 7. And q was -5. So it's f of x equals -1/4 times x minus 7 times x plus 5. Because we have a negative q, and we have to do minus -5, which turns it to a positive. Last example from a table. Remember, always look for that middle point or that pattern in the table. So if I look at the table here, I have 6, 0, so that's the middle. The vertex is always the middle. Actually, we don't need the vertex for that one because in this one we're looking for the zeros. In a 0 or x-intercept, the y value is always 0. So all I need to do is look on the y side. Well, here's one of the zeros. So that means this is 1, 0. So p is 1. On the y side, here's another 0. So my second 0 is at 3, 0. So q is 3. Identify a third point, any point. It doesn't matter. I'm going to go with the vertex because that's what I've been using for the other two examples. So my third point, which is also my vertex, is 2, -2. So x is 2, y is -2. Once you know those key pieces of information, we're replacing these four numbers, p, q, x, and y. X gets replaced twice, the same number. So f of x equals a times x minus p, and then x minus q. So y is -2 equals a times x is +2 minus, I'll come back and replace p. X here is also 2. P is 1. And q is 3. So now I just keep going to solve. -2 equals a is going to stay the same. 2 minus 1 is 1. 2 minus 3 is -1. I multiply these two. +1 times -1 is -1. A equals -2. Divide both sides by -1 to get a by itself. So a equals +2. A negative divided by a negative is a positive. So now that I know a, I'm going to go back and replace a, p, and q. F of x equals 2 times x minus p times x minus q. P was 1 and q was 3. And I'm going to graph this really quick just to make sure that it looks right. So 0, 1, 2, 3, 4, 5, 6, 1, 0, 2, -2, 3, 0, and 4, 6. My a value is positive. My parabola opens up, which means I solved this correctly. Okay, so now that we've written the equation once we found a, don't forget that you can always use NSolve in your calculator to check. So just as a quick reminder, in a calculator page, menu, algebra 1, numerical solve. I can type all of this in the calculator. Don't forget about the multiplication sign before the parentheses. -2 equals a times parentheses 2 minus 1 close parentheses 2 minus 3 close parentheses, and then comma a. Tell the calculator you want to know what a is. 2, just like we found 2. So once you find 2 by hand, you can always go back into your calculator, use NSolve, type this in, plus comma a, with the multiplication sign in between the a and the first parentheses, and that's how you can check your work to make sure that you found the correct a value.